Good morning, everyone.
Good morning, Mr. Christopher. Good morning. Welcome. Thank you for joining us. Okay, good morning. My name is
My pleasure,
Joshua
sir.
Ajayi. Okay, my name is Joshua Ajayi, your host and co-host for this program. And the topic of our webinar is Decoding PV System Datasheets and Exploring Future Trends in Solar Technology. And then today we have Mr. Christopher, our guest speaker. We have Mr. Robert from Goat. We have Mr. Moses from J Solar. I'll give us the introduction on our Energypro network, and then we'll start with Mr. Christopher. At Energypro network, our motto says transforming the energy landscape. And our purpose at Energypro network is to bridge the technical knowledge gap between professionals and beginners in the industry, which we've been doing to foster collaboration, enhance knowledge, and empower individuals to succeed in the sustainable energy industry. And then that is what we've been doing for a while. We started with our beginners network to teach people that are just getting started in the solar energy industry. And we also have the Energypro professional network, which vetted this webinar this morning. So our focus is to provide a platform for experienced professionals to share their expertise, collaborate, and stay up to date with industry development. Empowerment is also one of our most important focus. We are bridging the technical knowledge gap in the solar energy industry by providing access to expert knowledge, training, and resources. There are many engineers and they are engineers. Let me say that they are engineers and they are engineers. They are professionals and they are professionals. So our goal is to empower ourselves, to strengthen ourselves in the industry. Development is also one of our core focus, to support newcomers in the industry, to support people that are just getting into the industry by offering our guidance, mentorship, and resources to help them get started and grow their career in the industry. We have two platforms majorly. The Solar Energy Professional Network, like I've said, that is what vetted this webinar this morning. And we also have the Solar Energy Beginners Network. I'm sure every one of us are here this morning, both the Beginners Network and the Energy Professional Network. And we also have different people across Nigeria that are here with us this morning. Lastly, before we get started into the first teaching for this morning, Energypro Network is powered by HS Technology Limited and Mastec Electric. And Energypro Network is actually backed by an efficient team of these two establishments and a community of energy professionals. So I would say we'll get a chance to actually connect with ourselves even after this webinar. So let's stay in touch. Mr. Christopher, I'll be passing the mic to you now. You can get ready to share your screen. Can you hear me? Are you here?
Yes, I can hear you.
Okay.
I'm here.
All right. All right. You can. I'll stop sharing my screen now. You can get ready.
Okay.
All right. So, Mr. Christopher is the CEO of Ezekiel Industrial Limited and Solar Service. So he's also a data analyst and a great professional in the industry. So we'll be learning a lot from him this morning. Let's get started.
Hello, good morning, everyone.
Good morning.
All right.
Good morning, sir.
Good morning. Good morning. It's my pleasure to be in your midst today. It's also a great privilege to be able to share knowledge here today. I call it a near knowledge sharing platform because there is actually no one that is an island. Even the beginners among us today would definitely have something to give us. Even from their questions, there will be things that we will still learn. So this is actually a great platform, and I want to sincerely appreciate the organizers, the person of Joshua and his team for putting this together. You know, I don't know. Can you see my screen?
Yes, sir.
Yes,
You can.
Okay. You can see my PowerPoint, right?
Yes, sir.
Okay, perfect. So, like he rightly said, my name is Christopher, Obada or Chenje, as the case may be. I am a sustainable energy advocate. I've been in this for, roughly a decade. And my joy is that this is actually one of the most important aspects of this renewable energy stuff. And not even important to you as a solar engineer alone, but even to the entire, global commitment to have us transition to clean energy. Let me tell you that this is one of the most important, we are the most important stakeholders in this movement because our decisions, the things we do, actually contribute greatly to people actually adopting clean energy. You know, see, this is like you trying to have it. This is like a prevention. Um, um, what's it called? This is like a prevention mechanism because you know it's expensive for you to set up a renewable energy system that ends up not really even giving you what you want. So for me not to waste your time, because I understand my time is just 30 minutes, I'll go straight to what we have to discuss today. Why decoding PV system data sheet is important. Understanding PV system data sheet is crucial for anybody that is involved in this, network of renewable energy. Because this actually holds the key to you unlocking, you know, optimal performance, safety, and even maximizing your investment. There's no how that you can fully maximize your investment in renewable energy without, doing the proper sizing. In engineering, there's something they call undersizing, and there's something they call oversizing. In my years of experience, I've actually seen cases of oversizing. You know, when I say cases of oversizing, what do I mean? I've seen different cases where people just put solar panels on the roof, and then the maximum PV, power of the inverter is far below the number of panels that they have on the roof. See, in this program, we're going to be looking at why all these are important. Understanding the data sheet of your PV models, understanding the data sheet of your inverters, understanding the data sheet of your battery system, why they are important. They are all, interwoven. They work hand in hand. So if you miss out on one, there's every tendency that you will actually make the wrong choice and your system will not really give you optimal performance. So in this, at the end of this, these slides or this presentation, we'll be able to look at, understand how to decode, our PV module data sheet parameters, the inverter specifications, the battery characteristics, and the MPPT controllers, and how they are important, to making a perfect, solar system sizing. Now, what are the key parameters that you see when you take a typical solar panel? These are the common parameters that you see at the back of your PV modules. You see maximum power output. under standard conditions. This is actually the total, that is actually the maximum power that PV would give you. Let's assume that there is a favorable condition. This maximum power is a rating of your module, and it is crucial for you, in also sizing, the maximum PV power of your inverter. When you want to select an inverter, there are key parameters that you look at, not just the load. You look at, whether for an hybrid system, for example, whether it is able to take a particular amount of PV that you want to use for your load. Because there is even a rule of thumb for sizing the PV power, which I see, a lot of, installers actually missed out on. In this presentation, we're going to be looking at it as we progress. Now, then you now have your open circuit voltage. This is the voltage when the circuit is open, when you have not connected your panel to a working system, where you have not closed the loop. The open circuit voltage is the voltage of that panel. Like, for example, if you want to test the voltage of a panel when you have not connected it to a system, the open circuit voltage is actually that voltage that your multimeter gives you. And it is important for us to size the maximum PV voltage of an inverter. Now, we also have the short circuit current. The short circuit current that's like a surge current. They call it surge current. It is useful for you to size these circuit breakers, because in it, for your PV system, for those who are compliant, who actually does proper installations, one of the protections that you are supposed to put is a breaker between your inverter and your PV array. So this short circuit current is actually important for sizing your breaker size or fuses, depending on which electrical component you are using for the protection. Then you also have voltage at maximum power. Voltage at maximum power is different from your maximum power voltage. Voltage at maximum power, it's that voltage when you get the best out of your panels, right? When you connect your system, when your system is in loop, right, and it is performing at maximum output, it is that voltage that is your voltage at maximum power. And that voltage is what you use to check your MPP voltage range. When you look at your inverter, there is a maximum PV voltage and there is MPPT range. This voltage at maximum power is what you use by the time you have maybe a system of solar panels in series. It is the voltage at maximum power that you consider to ensure that the cumulative, the resultant voltage of your array falls within the range of your MPPT input voltage range. And then we also have current at maximum power, which is also similar to this voltage. That is the maximum current at the maximum power of your array output. We may not really have all the luxury of time, just like Joshua said, that this is just the beginning. Would have actually looked at a lot of things, how your solar panel performs, what is the maximum power at a particular temperature, because apart from this, you also see module efficiency. Most of your solar panels actually have their efficiency. So when we say that your output is your maximum power is 600 watts, which is another very common mistake that installers make. You are designing for a 2000 watt of load, for example, and you just get 5 sheets of panels and you say it's 500 by 4. That is you assuming that you are going to get 100% output from those solar panels, which is very wrong. Each panel has its efficiency, right? And it also has its temperature coefficients, cell temperature under normal conditions, irradiance, right? You see the panel irradiance that you are going to look at. the power output per area, right, of your solar panels at standard conditions, and losses that happens as temperature begins to increase below standard conditions. If we have the time in our subsequent what do you call, we'll be able to look at that. We'll be able to look at that as well. But now your module efficiency, when you look at your solar panels, your data sheet, you see the efficiency. So far, so good. The maximum efficiency I've seen is 23.5. You know, we heard that one of the companies, one of the OEMs, we've been able to achieve 30%, you know, output, right? So, but what is common in the market today, the highest I've seen in our own market is like 23. So that gives you the output to the irradiance ratio. You know, we'll actually look at the irradiance as we progress as well. So you'll be able to know what you are expecting to get from your solar panel at a particular temperature, right? So temperature coefficient, because solar panels, as the temperature begins to increase above the standard conditions, the output of the solar panel can sometimes begin to reduce. So for most solar panels, you see rate of change in Pmax, rate of change in VOC, rate of change in, that is the open circuit voltage with temperature. So it will give you, for someone who is actually trying to be very accurate in his design, you'll be able to know what you will get at every temperature from your solar module. That's what these parameters will help you to achieve. And then you also see cell temperature under normal conditions. It helps you to estimate the real world performance, right? You'll be able to estimate the real world. They say this is 600 watt. You don't just say, oh, it is 600 watt I have. So if I put 600 watt into 4, it will be able to cover for the load. That is actually very wrong. There is a rule of thumb, which if we have time to meet again to discuss, we'll be able to go deeper into some of all those parameters and how they will help you to be able to estimate exactly what you'll be getting from the solar panels. Then you have this STC, the standard conditions used for testing. So in most cases, the performance of your inverter and the parameter they've given you is at SCTs. That is why this temperature coefficient is helpful, is useful for you to be able to say, okay, as the temperature is not exceeding, you know, this standard temperature condition, what will happen to my panels? What will the performance be, right? So because of time, let me move. Now, so this is a data sheet snapshot from JSolar. I hope you all can see it. If you look at it now, this is for, I'm moving my mouse, if you can see it, this is for different, you know, capacity, different ratings of panels, not one. This is for 580 watts, 585 watts, 590 watts, 595. So you now see that they've given you different parameters. Here, they've given you the rated maximum power for each of them. They've given you the open circuit voltage. They've given you the maximum power, which I've explained before, the short circuit current, the module efficiency. Look at it. The highest here for JSolar is even 21.6. No, this is not to say that it is 21.6 of the 600 that you are going to get. You will get more depending on the irradiance. That's why I said, as time permits, we will be able to go deeper into what all these parameters is and how you'll be able to accurately estimate. So this is the power tolerance, and I mentioned the temperature coefficient. Look at it at the temperature coefficient of the current at maximum, that the short circuit current, the temperature of the VOC. You can see here now that the Pmax, you know, will reduce. Your Pmax and your VOC will reduce. That is why it is negative. The Pmax and your VOC will reduce as the temperature increases by about 0.275% per the temperature per a single degree Celsius increase. That is, as your temperature increases above the standard testing condition, the maximum power of your system will reduce for this very system by 0.3. That's about 0.35%. You get? So it means that you know it's a common belief that the higher the temperature, the higher the output. It is not true. As your temperature goes far high, sometimes the output, if the cell temperature actually goes above the standard testing condition, sometimes your output can reduce. I believe most of us actually didn't know this prior to this time. I'll move. So PV module data sheet, practical consideration. So now you will know that there is a derating for temperature. That is the takeaway. We have found out today that as your temperature goes above a particular condition, even your system gets derated. That is, the output, the efficiency reduces. You get? So the importance of temperature conference. So in hot climate, you'll be able to practically know what you are getting. If you know the temperature, the environmental temperature, atmospheric temperature, you will be able to know what output you would get. That will also even help you, because we have a lot of issues. So many inverter ratings that are not really what they are. Some of all these ones that our people go to China to bring, because of the regulation is not quite tight. So you will even be able to know whether those MPPT claim that most of all these inverter actually tell you whether it is true, because by the time you can do your calculation, then you know what to expect at a particular temperature. This is why this is also very important. So then let's move to the inverter data sheet, the key electrical parameters. So like I told you, these guys, they work hand in hand, and the knowledge of order will help you to be able to match the other parameters in the other system, so that there is no mismatch. Now, the inverter also has its own maximum DC power. For your inverter, you will see that the total PV input the inverter can handle. That is what this maximum power PV input. Some inverter put it as maximum PV power, right? So here the slides put it as maximum DC power, but what you find in most data sheets is maximum PV power, right? So it is telling you this is the total PV input your inverter can handle. They will give you for voltage, they will give you for power, right? So you will now be able to size appropriately, not you just put. That is what most installers do. I've seen that in most cases where someone has invested a lot of money and is not even getting the outputs, because what you have there cannot even convert fully, optimally, the things that you have on the roof. You don't put into consideration your maximum PV power for the inverter. So because when you now know your maximum PV power for the inverter, then you know, okay, how many panels can it take? And if you are looking at, okay, I want to achieve this number of PV array on my roof, then you have to check the maximum PV power of different inverters to see which one actually matches what you want to get. So in your design, like I was telling some of my students last time, I said, first of all, not just your load. You don't just say, okay, I've sized my load. My load is 2000 watts. So that therefore, if I have an inverter of 3.5 kilowatt, it should be able to handle stuff. No, you have to look at, okay, for that 2000 watts, how long do you want it to run? What is the PV, total PV power that can do what you want to achieve? Charge the battery efficiently and be able to carry the load, and maybe battery run overnight. So it's from there. You have to estimate the total PV input that you require before you select your inverter. Don't just say, oh, the load is 2000. About MPP voltage range. In the other section, I've mentioned this, so I'm not really going to waste much time here. But this is actually what you consider when you are looking at what your VMP, the VMP of your what's it called, of your solar module, is what you use to you make sure that it matches the total, the resultant VMP of your solar modules that you have in your array to match this. Then number of MPPTs. Some inverters actually have more than one MPPTs and different strings. So now if you have inverter have one MPPT and two strings, for example, it means there are two inputs. So what that means is that you look at that, okay, the cumulative, because when there are two strings in an MPPT, it means there is a parallel combination in the inverter, because the MPPT is one. So you ensure that the current combination of the two different strings will not exceed the maximum PV current also, because your inverter also has maximum PV current. So that is not actually captured there, but it's also there. You see maximum input voltage, maximum input current, all that in your PV side. Then you look at the AC side. The AC side gives you the power. That is the continuous power delivery when it is in watt. Let's take note that there is a difference between kVA and kilowatt. You know, because your kVA is not, your kVA is your apparent power. It's not the continuous power delivery. It is when it is kilowatt that it is the continuous power delivery to the grid or to your load. So you have to look at what the power factor of your inverter system is to be able to know what the exact power is. So you look at the grid compatibility, the voltage, the frequency. You know, you've had people say generator is not charging this inverter. The generator is not charging in this inverter because the inverter has a frequency range that it allows. For our own system is usually 50, 60. So when your generator frequency is below 50, it will not be able to charge your inverter. In most cases, when you are just running up and down trying to see why generator is not charging, it's just the frequency. So all these parameters are important. None is not important. So you must take time to learn how important each of them is to the entire system. So you have the THDI. This is actually the total harmonic distortion. You know, your inverter these days, any inverter you see, they will say it is a pure sine wave. It is pure sine wave. But let me tell you that is because the regulation is there is a porosity in the system. It's not all the inverters that are really pure sine wave. Some of them, when you see that the THDI of an inverter is very high, it means that inverter has a high current distortion. So see, I've done an installation for someone that they said anytime they want to, they are on inverter, the decoder will not peak. You get, some appliances are very sensitive to current distortion. So, and when the THDI of your inverter is very high, it means that the purity of the sine wave, the waveform of your inverter is deeper. There's less purity there. So let's take note of that. Usually for pure sine wave, it's actually supposed to be, less than 0.3 percent, within 0.3%. When it is getting too high, you know that your inverter is already deviating from a pure sine wave to modify or whichever, but the purity of the waveform is actually decreasing when your THDI is going up. Now this is the data sheet of a grow-out inverter. You can see. This is a data sheet of a grow-out inverter. You see maximum recommended PV power. So like we talked about before, this is actually the highest PV power that you can put. And then in some inverter, you see the maximum usable. That is to say that it is not all, when you put, that's to also tell you that, like I've also mentioned, you make sure that you match this with the PV rating of your solar array, that whatever you are putting on the inverter cumulatively will not exceed this. Then the maximum DC voltage, I've said it. This is the input range on the PV side. When you put your solar arrays in series, the voltage should not exceed this. That your VOC, in this case, you are using VOC. Your VOC, the accumulation of your VOC should not exceed 1000. This is what I mean. And the minimum of your VOC must, for this very inverter, if you put panels together and the total voltage is not up to 160, it will not start. The inverter will not see your panel. So then this is the range. This is where you use your VMP. You ensure that the cumulative VMP of your PV array is within this range. You shouldn't exceed it. If it does, there will be challenge. There's tendency for you to damage your MPPT. Then this is the number of MPPT strings. This is your string. So this has 2 MPPT tracker, and this has 1 string per each of the MPPT tracker. So this is I told you about current that time. This is the maximum input current per MPPT, right? So you cannot put, this is critical. See, if you look at some panels have high voltage, low current. Some have low current or high voltage, right? So the other way around. right? So when you are sizing, it is important that you look at this inverter, for example. The maximum input current per MPPT is just 12. You get? So it means that you cannot use any solar panel that has MPPT current of above 15. This is something people neglect, but let me tell you, 90% of, and that's why you see some OEMs, they don't want to even honor warranty terms, because they've seen things. A lot of the issues that arise from inverter failing is as a result of this, right? So you must make sure that you ensure that each of the parameters, the cumulative parameters of your array, match perfectly with this. So this is the output side. This is your maximum apparent power. You know, I told you apparent power. For this very inverter, the efficiency is very high. So you see that the apparent power is almost equal to the nominal power. So this inverter is giving you about 100%. So you look at all these things, it matters. So don't go and for inverter where the apparent power is not equal to that, is rated in kVA or VA, for example, and then maybe the power factor is around 0.8, for example, you go and put, maybe it's 4,000, you go and put 4,000 load. It's a problem. It's a problem. And you look at the surge power too. Does it have the surge power that can even take, like some of you that size for AC, and some of these motors that have a surge power, that startup power is higher than the running power. You have to look at the surge power of your inverter, or the maximum, the overrating power of the inverter, depending on how they put it. But most times it is the surge power or the overrating power of the inverter that you look at. So these are the battery side. They've told you this is an high voltage system. You can see they are telling you that the battery range is 100 to 500 volts. It's not 40. This is not a 48 volt system. So these things are important. So what that means is that by looking at this, you already know that this is an high voltage inverter. So you need a series, an high voltage battery that the voltage will be from the range of 100 to 500. Other than that, the inverter will not respond to you. So this is the continuous discharging, and for the battery, yes, right? So this is the maximum charging and discharging current. So this is also key. See, for your battery too, when you look at that, so I want to, while we are here, let us look at it. When you look at your battery parameter, you see maximum charging current, maximum, minimum charging current, optimal, nominal, like that. So if an inverter charging current is 25, for example, which is the maximum, and then you put a lithium ion battery where they said, okay, let the charging current be around 50, or you put so many lithium ion battery in parallel, you get at night, by the time they now put a load on it, it runs down. You say, oh, we have about that many panels on it, you should have charged, but the charging current is low, so the charging is going to be very slow, right? So you may not really get full no matter what you have on it, because the inverter has a limitation. You get, it's not a limitation, but then what I call limitation here is that there's a limit, there's a cap. You get, it cannot be exceeded because it is maximum. So all these parameters are very important. This is a backup power. This inverter actually has two output points. That is why you have a backup power and you have output AC. So it means it has two output ports. You know, you can connect, load to, you can do like two outputs. Anyways, I hope you understand. Then if you look at this also, you see the maximum efficiency of the inverter. You see, the other one is I think I've gone back. The other one is 98, while the other one is 95. So that efficiency will tell you, that is why you see that kilowatts, they are the same, because the difference is just very minimal. So inverter data sheet functions and environmental communication protocols. The inverter also has communication protocols. So in trying to do select your inverter, it is also very important that you look at those batteries that are compatible with that inverter, that communicate with them. Cooling, all those are the certification IP rating. The IP rating will tell you whether the inverter can be installed outside or whether it is an indoor inverter. IP66, for example, is an inverter that has a waterproof or dustproof, so those can be comfortably installed outside. So try to understand what this rating mean and their significance. So this, we are now I'm trying to round off. I don't know, I think my time is fast spent. In the next 3 minutes, I should be done, or 5 minutes, please. So this is interpreting battery data sheets. So it's also the same. Your battery is 12 volt, 48 volt, like that, you know. Then there are low voltage and they are high. For lithium ion battery, there are low voltage and they are high voltage. Those high voltage are the ones you can connect in series. The low voltage cannot be connected in series. If you do a mistake of connecting these low voltage batteries in series and fixing if they are with, there will be an explosion. So please, let's take note. So this is a typical data sheet of a Dynas battery. You can see this is the nominal battery. This is the rate. This is the capacity, the voltage. Let me tell you. Okay, this is the operating range. Recommended charge. This is the recommended 0.5 C. Your C is 100 amp hour. You can see it here. That's your nominal capacity. And the OEM has recommended that you charge at 0.5. What is 0.5 of 100? And that is 50, right? So imagine now you are now charging with 25. It's going to take time now, and it may even affect the battery performance. So it's key that you know. So when you are selecting an inverter, you have to look at, what is the maximum charging current of that inverter? And what is the recommended charging current of my lithium ion battery? So when you now have about 20 of these in series, for example, in parallel, I meant to say, you know that the demand has also gone up. So let's take note of all these parameters. Now, battery data sheet system design relevant. It will help you determine backup duration for usable kilowatt hour. So when you know the depth of discharge of your battery, when you know the capacity, you'll be able to appropriately size. The kilowatt hours is the number of kilowatts of that battery can discharge in 1 hour. So when your battery can discharge, for example, 1000 kilowatts, when you have 5.2 kilowatt hour, it means that is 5200. It means that it is 5,200 that it can charge in 1 hour, right? But the depth of the charge of the battery sometimes can be 80, can be 90. So if you divide it by 0.8, if it is 80, or 0.9, then you now know what you can get from that battery in 1 hour. So assuming now that you will have a particular load, you know, if you divide the total kilowatt hour of that battery by the load, you will know how long that battery can go with that load, considering the depth of discharge. So, you know, parallel and series configuration, I've mentioned that before. You ensure that, you know, the voltage, the current, the match, whether they are low voltage, whether they can do series, whether they can do parallel, that are important. And they must also align with your inverter voltage and charging specification. Then use of BMS for consider ambient temperature. So for MPPTs, it's not different. What we have mentioned for your inverter, we talked about you see the solar side. So that is what you have, because your inverter, your hybrid inverter has an inbuilt MPPT. So the specifications are the same. You must look at it, make sure that they match, you know. Choose your PV module. I've mentioned that before. Your inverter must match with your battery voltage, and the rest must match with your load and all that. So I've talked about this, right? We will not really have time to do this. Maybe we'll share this slide with those that are environment, because it's a case study example. Every specification tells a story. Try and interpret it. Take time to Google is your friend. Read it up. Try to find out what's the significance of this specification. Why do I need it? Research. Try to find it out. You get? Use data. Use those values conservatively. You must religiously. Don't overlook them. They are important. You know, cross-check between components make sure that there is compatibility between, you know, what you want to put on your roof and what you have in your inverter, and even the battery charging current, like I've all mentioned. Check for compatibility. You know, they say better interpretation leads to better performance and lower cost of ownership. Thank you for your time. I'm sorry that I head into the next speaker's time. I'm very sorry.
Thank you, Mr. Christopher. Thank you so much. I know some of us have questions. You can please drop it in the chat box or write it somewhere. By the end of the third section, we'll be taking all questions. So we'll have Mr. Moses up next. Mr. Moses is personally my oga. You know, he's a big name in the industry, and we'll who really learned so much from me this morning. So, Mr. Moses, can you hear me? Good morning.
Yeah, good morning, Joshua. Good morning,
Morning,
everyone. Hope I'm audible.
Yes, you can start preparing to share your slides, sir.
Okay, so thank you, Mr. Christopher. I think you've already laid the foundation, and I think you've already explained everything. So I don't know what myself and the other guy is going to say again. So notwithstanding, I'm going to share my screen. Just touch base in what he has mentioned, and everything I has mentioned is absolutely the facts. All right. I don't know. We Nigerians, we don't like manual. All right. When you buy a car, there is always a manual in the car, but we don't read it. If you buy a fridge, there is always a manual that comes with the fridge, but we don't read it. All right. So the same thing is applicable to our data sheet. Our data sheet is like a manual. All right. So before you do anything that you want to do, you just have to go through it. I don't design blindly. If I'm going to design, you need to bring out all the old data sheets that you are going to use. All right, this is a solar system, and solar system comprises of the solar PV, which is the generation, all right, which is the generator. There you have your MPPT, you have your battery, you have your inverter, depending on the system that you want to do. So if you're going to have your solar system, you need to have the data sheet of each of those equipment. All right, sorry, I don't have much time. Like when Joshua told me that it's just 20 minutes, I said, what do I want to do with 20 minutes? But let's just see what we can do. So I'll be sharing my screen now. If you can see it, yeah, just let me know. All right, I believe my screen should be audible now. Should be visible rather. Okay.
Not yet from my, okay, it's coming up. Thank you.
Okay. All right, so can you see it now?
Yes, clearly, we can see it now.
All right, so let me just put it in presentation mode. So yeah, it's clear now. All right, so my name is Moses Ezekiel. I'm the pre-technical sales and system solution manager for JA Solar. All right, so I'm sure we all know JA Solar. We manufacture tier 1 solar module, and the brand is not just top notch, the quality also stands aside. So let me just move on. We don't have much to say here. Okay. All right, so let me just move on. What's happening? All right, so yeah, this is, sorry, I had to bring this out because I might want to be explaining. Yeah, so this is just basically what JA Solar stands for. We are founded in May 2005. We are listed in the Nigerian Stock Exchange in 2019. Accumulatively, we've shipped 280 gigawatts as our first quarter of 2025. We covered 178 countries and regions. The market share, the global market share that we have is 14.5, and we've patented over 1,899. That's what we hold, the patent that we hold. All right, so yeah, let me not bore you with this. Let me just go to this. So this is the value chain of our PV. JA Solar, we don't manufacture, we don't assemble, we actually manufacture. And on the screen here, you can see the value chain. You can see the component that we have to bring together to form the module that you see. So we have the silicon rod, we have the silicon wafers, and we have the cells, then we have the module itself. All right. Then once you have the module, you can use it to deploy. And before I move on, I also want to let you know that JA Solar, we don't only manufacture a panel, we also manufacture BESS battery. All right, but I won't be able to talk about that now because I have limited time. All right, so now this is the cell roadmap. I heard when Mr. Christopher was talking about efficiency. All right, so efficiency of the cell of the module has to do with the technology. All right, so now when you look at these charts, underneath it, you can see the cell technologies that we have. We have the pack P type, The pack stands for passivated emitter and rare cell P-type. We have the TOPCon N-type. TOPCon stands for tunnel oxide passivated contacts. We have the HJT. HJT is heterojunction technology. We have the XBT back contact, and we have the peroxide silicon tandem. Now, all this technology has to do with efficiency. Now, when you look at underneath it here, you can see that this is a P-type. When you look at this, the P-type as a 2025-81, the efficiency is 24.10. Now we are discovering the same efficiency in the second quarter. So as a result of that, we've discontinued the P-type. So due to efficiency, we've moved to TOPCon. That is what we have in the markets. All right. So as the technology is improving, the efficiency is also improving. So when you look up here, you can see we have 33.60, which is for these peroxide silicon tandem. All right, so that is where we are going to. All right, so technology doesn't stop at P-type. All right, it continues like that. So whenever you are buying your panel, ensure you check the type of the one you are buying. All right, so that you can model up the efficiency. All right, so yeah, this is our data sheets. I saw Mr. Christopher uploading our data sheet. So this is it. No, so now, if you check this data sheet, there are some key parameters that you need to focus on. All right, so now when you look at this, this data sheet has IC 61215, which means that it has been tested for performance and reliability, and it has passed. All right, so that is the reason why you will see the comprehensive certificate here. Same thing with IEC 61730. It has undergone safety test and it has passed. Now, when you look at this premium modules has a higher power generation. All right. Remember, if you are doing a large capacity, I'm sorry to say this, I don't really focus more. I don't really put more energy when it comes to residential. All right, I'm sure a lot of people in this class knows that I don't really put much effort, and the reason is simply because I love doing a quality installation. All right, and I love taking my time with the design to ensure that it's gotten accurately. But I'm sure you know that residential will not accord me that opportunity, you know, because of the cost. So they just believe let's do anything, and I think we need to change that. And I'm going to congratulate Energypro for bringing this out. You know, let's try and penetrate the technicians. All right, let's try and penetrate the grassroots, those that they will just come and do installation for me, and off the top of their head they start saying you will use 5 panel, you will use 6 panel. You know, such pisses me off. How do you know? You didn't even ask the person, what is your load, how many hours do you run this load? You are just given design off the top of your head. It is not done that way. So, and I believe that this platform from Energypro is going to address that. All right, so let's bring in quality into our design. So now higher generation, better higher power generation, and you have better levelized cost of energy. All right, so now lights, you can see LID, then you can see better temperature coefficient. LID has to do with the duration. All right, because your first year, when you are installing your panel for the first year, you usually see 1%, but subsequent year till the lifespan of that module, you are going to have either 0.4, 0.5, 0.3%. Those values matters, all right, especially when it comes to CNI or utility scale, because you need those parameters to know how you are going to be generating revenue. All right, so that is what JA Solar stand for. You know, our panel has a better return on investment as a result of the higher generation. All right, so now I'm sure most of you have been seeing JAM 66D45. So this is just the interpretation of it. All right, so the JA stand for JA Solar. All right, now M there is not module, because most people might be thinking it's module. M there stands for monocrystalline, because we previously had what we call JAMP. That's GAP, and that P there stands for polycrystalline. So just take note of that. Now, the 66 that you see there stand for cell. So we have 54 cell, 60 cell, 66, 72, 78. All right. Now, D here stand for either bifacial or monofacial. So whenever you see S here, it's called monofacial. Then your 45 here, you can see stand for the size of your cell. All right. Then at the end of it, you see a module power. All right. Then at the end of it, you will see either MR, MB, LR, LB. So this is what it stands for. All right. So the XSL stands for the power, depending on the type. So let's move on. All right. I'm sure I'm still audible, right?
Yes,
Am I
sir.
still audible? Okay. I'm coming. Let me just move this. All right, so this is the data sheets. I'm still explaining the data sheets, all right? So now, in a data sheet, you will see mechanical properties and you will see electrical properties, all right? Both are very, very important. Both are very, very important, all right? So now, when you look at this module, for example, now you see that the length is 2382 millimeter and the width is 1134 millimeter. And the reason why it's very important is because if you are doing your design, all right, you need to do a layout, all right? If you are using SketchUp or you are using PVKs or you are even using AutoCAD, you need the dimension to do a layout. So dimension is very, very key, okay? Now, when you look at this, we have draining holes in 18 places, all right? Then we have mounting hole in 4 places. We have the next tracker in 8 places, and we have the grounding hole in 8 places. So our frame is carefully designed to ensure that all the parameters that will help you in doing your mechanical installation is already there. So you don't need to drill, you don't need to do anything. All you need to do is to bring in your clamps and fix it in. All right. So you have where you are going to do your grounding, bring in your cable and plug it in, you are good to go. All right. If you are designing, if you are using a tracker, the holes that you're going to put on your tracker is already there as well. So all you need to do is to fix it in and you're good to go. All right. Time will not permit me. I would have loved to delve deep into these mechanical so that you will see that everything is made easy for those that are for the installers. All right. If you are doing a roof mount, there are holes for you to put in your clamps so that everything becomes easier. So looking at these parameters now, cell is mono, as you can see. The weight is 33.1 kg. Now, all these parameters are not just there for you to just overlook. They are very, very important. If you are doing a roof mount, weight is very, very important. All right. So this is the dimension. You can see the cable size as well, 4 mm. Even if you've done your cable analysis and you realize that you can actually use 2.5 or 1.5. I'm sorry, the rating starts from 4 mm and so on like that. You don't use 2.5, you don't use 1.5. I don't even know if we have solar cable as low as 2.5 or 1.5 in the market. I doubt. Or has anyone seen the rate such rating of cables in the market? I doubt. It's not. Now, number of cells is 132. That is 6 rows and 22 columns. Now, junction box is IP68. Mr. Christopher mentioned this as well. The IP rating is very, very important. So the junction box of JA solar module is IP68, meaning that it is waterproof and dust proof. All right. So you can see 3 diodes. Now, every module, have diode, and I'm sure you know the function of the diode. The function of the diode is just to prevent all the modules from getting shaded. All right. I'm sure you know the effect of shading. It's decrease generation. So we have the bypass diode, so that once one side is shaded, the current is bypassed to the other one, and you still have your power. You understand? You still have substantial power to roll with. All right. So the connector is QC4 and MC4. Now, the reason why we J Solar is always there for you from the planning of your installation to the execution is because we want you to have a sweet installation. All right. Now, in Nigeria here, we've not even done a single installation of 50 megawatts. We've not done a single installation of 100 megawatts and so on like that. All right. I don't know, maybe because we don't have the capability or we don't have the manpower, but I feel it's doable. All right. So I'm pushing it out to anyone in this group now that if you have such capacity, you can always reach out to me. Then we'll walk you through all the steps. It's the same thing. All right. I think people in this group know me that I always tell them that I love higher capacity. Let the challenge be higher. All right. Don't bring 5 kilowatt pin to me. Don't bring 10 kilowatt. Bring 50, bring 100. We'll run it together and everybody will learn and the installation will be top notch. So that is what we stand for in Genius Solar. All right. So you can see the cable lengths, portraits, landscape. You can see the thickness of the glass, which is 2 mm. Then packaging and configuration, 36 pieces per pallet in case you want to ship. All right. So let me quickly move on so that I won't eat into the time of Mr. Growat. Okay. All right. So this is the electrical property. Mr. Christopher has said much here. So I'm just going to play around with it. All right. So this is the electrical property, and we have different power ratings. We have 595, we have 600, we have 605, 610, 615, and 620. All right. So the key parameters are what I've listed there. The VOC. VOC is voltage with no load connection. All right. If you bring out your panel and you are testing it, what you are getting is the VOC. There is no load connection to it. Now, VMP is the module best performance. So every designer strives to get the VMP and the IMP, all right? Because that is where we have our best performance, the VMP and the IMP. And the good thing about this is that remember the flow that I mentioned earlier from if you're doing a grid-tied system, all right, where you have your inverter and your PV system. So if you want to know the VMP, because your module is actually going to be arranged, all right, to feed into the inverter. In terms of grid, I'm talking about grid tied now. So you arrange your module to feed the grid tied inverter. And how do you know how to arrange your module? You know how to arrange your module by getting instruction from the inverter. And what are the instructions? The data sheets. All right. The data sheet of the inverter will specify how you need to arrange your module so that all the electrical parameters that you're going to put in place will make the inverter very, very agile. Will make the inverter to work accurately. All right. So that is, you can see the importance of data sheets. So if you're going to check your inverter, they will tell you maximum open circuit voltage. They will tell you MPPT voltage range. All right. They will tell you maximum current per MPPT. That is what you've seen in the inverter data sheet. So once you've seen that, then you come to your module and see how you can arrange it, knowing fully well that connecting your module in series will increase the voltage and connecting your modules in parallel will increase the current. So once you have that, then you can manage the arrangement of your modules accordingly. You also need to factor in temperature. All right. Like I mentioned, as a designer, you don't limit your design skills because you don't know where you'll be designing in the future. You can be designing in a region with extreme cold weather. So how do you do your design? You understand? You need to factor in temperature. So this is where all this temperature coefficient comes into play. All right. Now you can see the power tolerance. Power tolerance is 0 to plus or minus 3%. It means that though my module is 603, it can also go as far as 3%. So that is the meaning. All right, so now let me move on. So you can see the curve here. Let me move on. So this is also the electrical parameters. Remember, the module that we are looking at is a bifacial module. It's a bifacial module. I think I've spent much of my time. Oh, so let me just run through it. Let me run through. So this is the bifacial module. This is also another parameter that you need to factor in, because it is not every time that you use a circuit breaker for your installation. According to IEC 62548, string overcurrent protection in the combiner box or string harness system is required if the number of parallel connected string multiplied by IC short circuit, that's for the module, is greater than the, you can see maximum series fuse rating 35, then you can use it. If it is not, then you cannot use it. So it is not all installation that you start saying you want to use your circuit breaker, you know. Yeah, especially when it comes to string inverter. But if it is a centralized inverter, you can go about that. So this is the bifacial ratio. Even if the power rating is 600 watts, once it's receiving power from the front and from the rear, the power can go as far as 680. All right, so you need to do your design to know how this will work out. All right, so this is the bifacial ratio as well. So you can see how it is 625, but for the bifacial, you have 675. So this is our monofacial module. I'm sure we have the same thing there. So you can see for the coefficient tells us how much the panel's power output decreases for every degree Celsius. So that means if your temperature is increasing, all right, above the 25 degrees Celsius, so you need to do your calculation to know how you're going to do that. So now, let me just use this to end. This is actually a few tests regarding our module, all right? Now, remember, if you're going to do your installation, you must have done your simulation, all right, using PVCs to know what generation is going to be, to know what the degradation is going to be. So running through this, our simulation, the first year degradation gives 0.82 and 0.84%, which is lower than the 1% standard, all right? So the actual generation is also 11.3% higher than the PVCs predicts. All right, this is just to show you how good and how efficient the solar module is. So I think this is the last place. All right, so this is where I'm going to end for today. All right, so sorry that I into the time of what's it called? Yeah, I'm sorry about that, Mr. Roberts. I'm sorry about that. All right, so I think I have room for question. If you have any question, feel free to ask. If you have any question, feel free to ask. Any question? Sorry, am I audible? All right, Joseph, you
Yes,
can ask
you
your
are.
question. I think.
You are.
All right.
Yes, sir.
Okay. All right. So, good morning, everyone. I wanted to hold on till the whole session was over because I couldn't ask for the previous presentation for the previous presenter, but it's fine since I could ask question now. So thank you so much, Engineer Moses. You always top notch all the time. Thank you so much, and I'm happy to see you at GK Solar now. Thank you so much. You're going to help us a lot there. And thank you so much to the organizers of this event. I want to speak on a question here on the solar home system that you, not that you are against it, but you kind of feel that for solar home system we whenever we want to design, the effort we put into this design does not really match what the output is. And thanks to Energypro network, they are trying to also build in that understanding among technicians because it's challenging. So what I want to ask is, in the situation where we are doing our standard work, because I'm somebody who do not do much work. The reason why I do not do much work is because I do my work carefully. Most of the time when I get all these kind of requests that are outrageous, I just push it out to somebody else and hold my sanity. Because of that, I've not, over the years, I have not had the system where clients will keep calling me, except one, and that one I understand how that one happened. So that it was a existing installation, and I had to go and optimize their system. And ever since then, they've been adding to their load and stuff like that. So I understand why I'm having that issues. But aside that, I've not done a design or deploy a system, and I'm being called back to either come and change anything there or what have you. Now I want to ask, in this case where we want to design a system and we put so much effort for solar home systems now, I will put so much effort, and you keep having a situation where after you've sent a bill to a client, they will, you like, for me, I used to build a relationship where I used to have insiders privilege. So I used to try to connect with somebody inside to get how what is going to happen next, know how to follow up and what. So if peradventure we design a system, we take our time. You know that designing a system is not just something you do in one day. It could take you 2 days, sometimes 3 days, because you want to ensure that you're not missing out on anything. After taking all your time to design, visit the site for assessment, and it turns out to be that somebody else came on with a bill that is half your price. What do we do if we keep having that situation? Because definitely you don't want us to lower our standard. But if we do not come down to this level, we won't see anything. What do you advise? Because I'm at that break point right now.
Okay.
What do you
Okay.
advise?
Okay. So what I would say is, I don't know if Joshua, I don't know if you've noted the question, because I want us to follow the program. You understand? I'm sure Joshua must have noted the question. So
Yes.
yeah, good. So when it's time for question and answer, then we're going to, there's time for question, answers, and discussion. So we are going to find a way around it. You understand, Joseph? Do you understand that? All right, good. So I think, sorry, Mr. Robot, I've eaten into your time.
All right.
So
Thank you very much, Mr.
No problem, Oga. Good morning, sir.
yeah, morning.
All right. So
Yes, sir.
let's quickly move to Mr. Robot, and by the end of this lecture, we can take all questions. You can also drop your question in the message box. Okay, Mr. Robot, welcome. Mr. Robot, I've been doing this for a long time, and we want to learn a lot from him just now. Please prepare to share your screen, Mr. Robot.
Okay.
All right. Thank
Good
you very
morning,
much.
everyone. Please, can you hear me? Good morning, sirs.
Good morning.
sir.
Good.
Okay, my name is Roberto Moshe, one of the after-sales technical support engineer for growers covering West African region. So today I will be running us through the technical data sheet for some of the most popular grower inverters in the Nigerian market. So let me quickly run through the slide. And then I will want to thank the Energypro team specifically for bringing us together and then sharing knowledge. And then to acknowledge the presence of my Ogatu, Engineer Moses and Engineer Chris. It's a pleasure to be on the same platform with you here today.
My pleasure, sir.
Yes, sir. Okay, please, can you see my screen?
Yes, sir.
Okay, so today I'll be running through some of the major model that we have currently in Nigeria for the off-grid systems and some of the CNI product that we actually brought them to the market recently. So starting from my slide, you have the SPF 3000 to 5000 TL HVM. So this is one of our best-selling off-grid system. It's a high-frequency system. So here is the data sheet. So on the data sheet, we have it available in 3 categories. The 3000 TL. So the 3000 TL is equivalent to like 3 kilowatts because our system is rated in kilowatts due to the fact that the power factor is rated 1. So whatever the rating is, the output power is same as the rating of the inverter. So battery voltage for 3000 TL is 24 VDC, And we have another 3000 TL that the battery voltage is 48 volts. And then another one, 5000 TL HVM. The battery voltage is 48 volts. Then the inverter output, we have rated power, like I said earlier, 3000 VA / 3000 watts. So the power factor is 1. So whatever the inverter total capacity is going to be the output the inverter will be given. And then for the 5000 TL, we have 5000 VA and then 5000 watts, which is equivalent to 5 kilowatts. So here we have the parallel compatibility. The 3000 TL 24 volt cannot be parallel. The 3000 TL 48 volt cannot be parallel. But 5000 TL 48 volt can be parallel. And the maximum you can put in parallel connection is 6. 6 of them connected in parallel. The AC voltage. So the AC voltage is within 230 plus or minus 5%. So that is the AC input voltage that the inverter can accommodate. Here we have the surge power. The surge power for the 3000 tier is 6000 VA. So what that means is, should in case of any surge, should in case of overload or anything, the inverter can withstand maximum power of 6000 VA for some seconds. And then for the 48 volts, same 6000 VA. And then for the 5 kilowatts, is 10,000 VA. So the surge power, 10,000 VA for 5 kilowatts, 6,000 VA for 3 kilowatts. The efficiency of this particular model is 93%. The waveform is pure sine wave, and then the transfer time is 10 milliseconds typical, and then 20 millisecond mass. That is the time it will take to transfer from grid mode to off grid. Solar charger, the maximum PV power for this particular one, 3000 TL 24 volts, is 1500 watts. While that of 3000 TL 48 volts is 1800 watts. Then for the 5000 VA, the maximum PV power is 4500 watts. So that is to say your solar array cannot exceed this figure. If you are going for 5000 TL, it's going to be within 4500 watts, which is equivalent to like 4.5 kilowatts. Maximum MPPT range. For the 24 volt, the maximum MPPT range is 30 VDC to 80 VDC. And then for the 48 volt, the maximum MPPT range is 60 VDC to 115 VDC. And then for the 48 volt, 5000 TL, the maximum MPPT range is 60 VDC to 115 VDC. Maximum PV array open circuit voltage. So your PV array open circuit voltage for the 24 volt system, which is the 3 kilowatt, is 102 volts. While that of 3000 TL 48 volt is 145 volts. Then that of 5000 TL is 145 volts too. So this particular point, most installers, they normally mistake this particular inverter, the 5 kilowatt of this particular inverter, for the SPF 5000 ES. So that one accommodates more power from the PV than this one. So it's a high voltage inverter. Meanwhile, this one, the maximum we can go for this particular model is 145, which is indicated here. Number of MPPT tracker for each of this model is 1. Maximum solar charge current for 24 volts is 50 amps. Then for the 5000 TL HVM is 80 amps. That is the maximum charge current. Maximum efficiency is 96%. Then the AC charger. Charge current for the 24 volts is 30 amps. For the 5000 TL is 60 amps. AC input voltage is 230 VAC. Selectable voltage range is within 170 to 280 mass. So your AC input voltage is acceptable between 170 volt to 280 volts. Then the frequency is within 50 Hz and 60 Hz, depending on your region. Then the physical parameters, we have the protection degree, which is the IP protection is IP20. Normally, this system is meant to be installed in an enclosed place that is well ventilated, which is not prone to direct sunlight or rain or any form of liquid coming in contact with the system. So the IP protection is low. So it's not supposed to be exposed to the sun, rain, or any liquid. So this is for this particular model. So let's go to the next one. So here we have the SPF 3500 and 5000 ES. So this is one of the most selling model for grower system. So this one can accommodate up to 450 volt from your solar array. 450 from your solar array. So let's run through the data sheet. So the battery voltage is 48 volts. Battery type is compatible with lithium and lead acid battery. Then the output, inverter output, rated power for the 3500 VA. The rated power is 3500 VA or 3500 watts. And here we have 5000 VA or 5000 watts. Parallel capability. This one, you can put them in parallel up to, it's actually 6 units. I think there is a mistake here. So the maximum you can put in parallel here is 6 units. Likewise, this 5000 ES. The maximum you can put in parallel is 6 units. Then the AC voltage is 230 VAC plus or minus 5%. The power surge for the 3500 watts, the power surge is 7000 VA. And for the 5000 ES, the power surge is 10,000 VA. The efficiency at its peak is 93%. The waveform is pure sine wave, and the transfer time is same as the one before, 10 millisecond typical, and then 20 millisecond mass. So the solar charge information, maximum PV power for the 3500 ES is 4500 watts, while the maximum PV power for the 5000 ES is 6000 watts. So that simply means it can accommodate up to 6 kilowatt peak from the solar array. MPPT voltage range. Here it is stated 120 VDC to 450 VDC. But for this particular model, practically over the year, we've discovered that the starting voltage range for the PV is actually 150. So if your PV array voltage is less than 150 VDC, it will not be able to, the inverter won't detect the voltage, it won't recognize the PV. So you must have at least 150 and above before it can charge your battery and supply power to the house. So the minimum range is 150 and the max is 450. The number of MPPT tracker here is 1. Maximum input current for MPPT is 22. And for this particular model, we have different versions of this particular model. There are some of this system that the maximum input per track for the tracker is 18 amps. We have for 22 amps, and then we have for 20 amps. So depending on the version you are getting. But the good thing is, in case you are doing your design, the system is being designed in such a way that even if you overshoot the current rating of the tracker, the system is designed to only take out the usable amount of current from your PV array, and then the remaining one will become a waste. It will not have any negative effect on the inverter, but you'll be losing power. So if you oversize the panel and your current is more than the rated current for this particular model, which is 22 amps, so the system can actually neglect the excesses and make use of what is suitable with the design, which is the 22 amps we can see here. So likewise to all our hybrid inverters. But the voltage is something you cannot play with. So the moment you exceed the voltage, it's going to be a serious problem. So you ensure that you always play along with the total VOC from your panel array. So it's even advisable to not to do exactly the maximum voltage. You can just be within, should in case of maximum sun hour or peak sun hour, so you will not overshoot the max VDC for your panels. I mean VOC of your panel array. So maximum PV open circuit voltage is 500 VDC. But for this one, we always recommend that you stay within 400 to 450 mass to be on the safer side. The maximum solar charge current is 80 amps for the 3500 VA, and then 100 amps for the 5 kilowatt inverter. So AC charge current for 3500 ES is 60 amps, while for the 5000 ES is 80 amps. The AC input voltage 230 VAC. Selectable voltage range 170 to 280 VAC for residential operations. So the physical component of this one, the protection degree is IP20, and the dimension, everything indicated here. So let's move to the next one, which is the 6000 ES. So here we have our, okay, let me quickly talk about this one first. This is our latest model that has been deployed to the West African market recently. So the SPE series. So it is available from 8,000 watts to 12,000 watts, meaning we have 10 kilowatts, we have 8 kilowatts, and we have 12 kilowatts for this particular model. So this particular model, we have the battery voltage as 48 VDC, and the battery type lithium, and then lead acid battery. Rated power is, oh man, I think there is a mix up here. There is a mix up here. So I'm coming, please. I think there is a mix-up somewhere. This is supposed to be for the SPE series. This data sheet, this one here, is a mistake on my own part. Apologies, please. So this is supposed to be for the SPE, the one I was explaining before I brought you guys back to this point. So the battery voltage is 48 VDC, battery type lithium/lead acid battery, and then the rated power for this, you have 3,500. Then parallel compatibility is 9. You can connect 9 of them in series. 9 of them can be connected in series. Sorry, please. Sorry, please. Please permit me to quickly get the data sheet. Sorry, please. Sorry, please. Sorry. Apologies. Okay. Okay. Please, can you all see my screen?
Yes, we can say it.
Okay, sincere apologies, please. There was a mix-up along the line. So here we have the data sheet for the SPE series, 8,000 ES, 10,000 ES, and then the 12,000 ES. So here is the input data, DC. Maximum recommended PV power for 8,000 ES is 10,000 watts. And then for 10,000 ES is 12,500 watts. And then for 12,000 ES is 15,000 watts. Maximum DC voltage is 550 volts. That is from your PV array. You can accommodate up to 550 volts from your solar array. Then start voltage is 120, but preferably 150 for each of these series, 150 and above. MPPT voltage range 60 to 480 VDC. Number of MPPT tracker for this one, for the 3 of them, is 2 MPPT trackers. And the number of PV strings per tracker is 1. Maximum input current per MPPT tracker is 27 amps. So this means for each MPPT, you can go as high as 27 amps for each MPPT. Then output data. AC nominal power is 8,000 watts for 8,000 ES, and then 10,000 watts. This simply means the power factor for this particular system, for all of our system, so to say, is 1. So maximum AC apparent power, 8,000 VA, 10,000 VA, and 12,000 VA respectively. Nominal AC voltage is 230 volts. AC grid frequency 50 Hz/60 Hz. Output current adjustable power factor for the 8000 ES is 34.8 amps, and for the 10,000 ES is 43.5 amps, while for the 12,000 ES is 52.2 amps. Output current, adjustable power factor is 0.8 leading to 0.8 lagging. The maximum conversion efficiency is at 96.5%. Then the battery data, nominal voltage is 48 volts, maximum charging and discharging power for the 8000 ES is 190 amps to 200 amps. And then for the 10,000 ES is 220 amps / 240 amps. For the 12,000 ES is 250 amps / 280 amps. That is charging and discharge current. Battery type is lithium / lead acid battery. Backup power. We have AC nominal output power of 8,000 for the 8,000 ES, 10,000 for the 10,000 ES, and then 12,000 watts for the 12,000 ES. So the switch time here is 20 milliseconds for single operation, and then 30 milliseconds for parallel operation. Then efficiency, peak efficiency is 96.5%, and European efficiency is 95.5%. General data. The dimension 550 by 465 by 155 millimeter. Weight is 21.5 kg. So I really want to point out on the IP protection. So it has the same IP protection with the ones I've explained earlier. IP20 is meant to be installed in an enclosed place that is well ventilated, that is not prone to direct sunlight and not prone to rain or any liquid dropping on it. So from here, I would like to take us back to the slide again to quickly talk about the commercial solutions. Our commercial solution, which is the WIT inverters. So we have them in ranges from 50 kilowatts to 100 kilowatts, and they are all parallelable. We can parallel them. We have the lower version of the WIT inverters, ranging from ranging from 4 kilowatt to 15 kilowatt. So here is the data sheet. But for the sake of time, I would like us to quickly brush through the higher capacity, which is the 50 kilowatts and above.
Them to restock, because I think they used to go to, I don't know, maybe inside something like where to go and buy them in big garden from. It's to rush it there, but it's cheap.
So let's quickly take a look at this, then I round up. So this is our commercial system. So it's available in for the higher capacity from 50 kilowatt to 100 kilowatt. There is 63 kilowatt WIT inverter. There is 75 kilowatt WIT inverter, and there is 100. For the off-grid operation, if you want to operate it without the grid present, for this particular one, 3 of them can be parallel together. But for grid operations, for grid connected installation, 6 of them can be parallel together to make 600 kilowatts. So let me quickly run through the data sheet for this particular system. So maximum recommended PV power for modules is 109.2 kilowatts. That is for the 50 kilowatt WRT inverter. So the maximum PV power is 109.2 kilowatts. Then for the 63 kilowatt WRT inverter, the maximum PV power is 128.8 kilowatts. And then for the 75 kilowatt WRT inverter, the maximum PV power is 156 kilowatts. And then for the 100 kilowatt, the maximum PV power is the same as that of 75 kilowatt, 156 kilowatt. This PV start voltage is from 195 volts, and the maximum input voltage is 1100 volts from your PV array. Maximum nominal voltage range is 550 volts to 800 volts. The maximum input current per tracker is 32 amps. So the maximum input current per each tracker is 32 amps. And the maximum short circuit current per MPV tracker is 40 amps. Number of PV strings per tracker is for 50 kilowatt system. The number of tracker is 7, and for the 63 kilowatt system, the number of tracker is 8. For the 75 kilowatt system, the number of tracker is 10, and then same thing with that of 100 kilowatts. So output data, maximum output power is 50 kilowatt because the power factor is 1, 63 kilowatt, 75 kilowatt, and then 100 kilowatt respectively. Maximum AC apparent power, 55 kVA. That is, if you want to do the rating in kVA, 55 kVA, 69.3 kVA, 82.5 kVA, and then 110 kVA. That is the maximum apparent power for each of these capacity. And then the nominal AC voltage range is 380/415 volts. That is, it simply tells you that this system is a three-phase system, three-phase input and three-phase output. Then maximum output current for the 50 kilowatt hour, for the 50 kilowatt inverter is 83.3 amps, and then for the 63 kilowatt inverter is 105 amps, and then for 75 kilowatt inverter is 125 amps, and for 100 kilowatt is 166.7 amps. So the AC grid connection type is, you can connect it three-phase wire system or three-phase and neutral system. That is three-phase 3-wire or three-phase 4-wire plus the 18 terminal. Input data from the AC input data. I think I've explained this side before. Then let's go to the battery. Battery data, continuous charging and discharge power. Here we have 56.7 kilowatt. Here we have 71.4 kilowatt, and then here we have 75.1 kilowatt, and here we have 113.5 kilowatt. Battery voltage range. The operating battery voltage range is from 600 to 1000 VDC. That is from your battery bank. Operating voltage range 600 to 1000. And then this is only compatible with lithium battery. So if you are going to go for any lithium battery, normally there is a customized batteries that we have for this particular model. We have the the APS battery, the ACE battery, and all of that. So it's there. Because of time, I won't be able to run through all this. But after the training, if you are interested in getting the slide, I can furnish you with that. Or if you want to get it directly from the website, we have a lot of models and their data sheet user manual available for your use from our website. You can directly download them from there. So
All right,
back off
thank you
power.
very much.
It's okay. So because of time, so I would like to round up here. So, but if you have any question, then you can bring them on during the question and answer section. Thank you so much for listening.
Thank you so much, Mr. Robert. Thank you very, very much. I can see we have some questions of it. So now we'll be going into the question answer discussion section of it. I get to start with Mr. Hilary question.
Okay.
Okay.
Mr. Moses, are you here? Yes, I can see you. Hello, Mr. Moses.
Okay.
Good.
Yeah.
Yeah.
Okay. Can you hear me?
Can you hear me?
Yes, we can hear you.
All right. So
All right. So
Hilary question.
Hilary
I think it's okay. I can hear myself.
myself.
Hello? Hello, can you hear me now?
Yes, we can hear you now.
Hi.
Yes, it's clear. We can hear you.
Okay, good. So now to Hilary question. You're trying to know how you can stand out among the roadside technicians, let me call them like that, so that whenever you quote, your quote should be accepted, despite the fact that you're doing the right thing. Well, so what I want you to know is that the industry is polarized already, right? And everybody is very conscious about costs. Now, if you are doing your own design, definitely you are doing it to the best of the equipment that you want to deploy. All right, you are putting in all the safety equipment, the breakers, and the rest. In fact, you can even go as far as checking if they have such, and you even want to do earthing. You understand? So you want to do an efficient design, but that efficient design that you want to do come at a cost. So if you tell people that you don't have earthing, you need to do earthing, they will say, is it not just to bury something on the ground? You understand? So I think for now, we just need to keep educating people. And thank God for a platform like this. When even the technicians, we need to bring them on board. And I believe with time, the industry will be regulated, all right, in such a way that if anybody wants to do a solar home system, all right, so you need to go through the right body. You understand? And you need to be registered you need to be even registered as a solar electrician before you can do such installation. You understand? So we are going to get there. It's just a matter of time. But as it stands now, just try and stick to your own customer. Keep doing what you know how to do best. An efficient system. Don't cut corners. All right, because if you do that, it will backfire and your name will be rubbed in the mud. So just keep doing what you know how to do best. Your own target market will come to you. There are people that still love doing, that still want to pay for quality. So you still keep meeting them. But those that don't want to, they just want to do anyhow, they also have their own market. So I believe with time, the industry will be regulated. All right, so just keep doing what you know how to do. Does that answer the question? I don't know if you're still in the robot is robot. I don't think it's inside. It's no longer in the room. All right, it's no longer in the room. So any other question?
Hello, good morning.
Okay.
Hello, good morning.
I think someone is trying to speak.
Hello, good morning.
Hello, good morning.
Good morning.
Yeah, thank you for the
Yeah,
wonderful.
thank you for the wonderful.
I have some questions that I raised in the comment section. I don't know if you can attend to it, please.
All right, let's do that. Um, I'm trying to see your questions. Okay, you said the question says, "Good morning, sir. My name is Emmanuel. Please, I would like you to dwell more on the charging amps and power of PV controller. For example, if a controller is rated 120 amps and 6,000 watts, why do some engineers load the controller with over this capacity and they claim it is still working well without any defects? Please kindly explain why and what is happening."
Oh, okay.
Oh, is a question? Is a question for me?
Question for me?
Yes, Mr. Christopher, you can help us with that. He's trying to say, okay, why do people load their MPPT and they say it still works?
See, the
You
truth of the
know,
matter is
see,
that
the truth of the matter is that
because of
because
Robert's
a
presentation,
robot
he mentioned that
he mentioned that
even if you exceed
even if you exceed
the maximum
the
input
maximum
current, that it's still going to
current,
work,
that
but
is
you
still
will
going
not
to
get
work, but you will not get
the
the
heat, right?
heat,
So for some
right?
system,
So
because
for
of
some
the kind of
system, because
safety
of the kind
interlock
of
the
safety
inverter
interval
has, it's not like it's a safe
like it's
practice.
a practice,
The truth is that is
which is
supposed
that
to
that is
damage
supposed
your
to
MPPT.
make your everything.
But it's
So
possible someone
sorry,
is
the
using.
feedback is too much.
Too
Can
much.
some of us turn
Can
off
some
our
of us
mic?
turn off our mic?
All right, is it good now?
Yes, it's better now.
Okay. So I said while Robert was making presentation, he made mention that you can even exceed their maximum input current. I've seen it's not like it does not work, right? But he talked about something that is critical. The truth is that has a tendency to damage your system because your system is there's a maximum surge capacity rating for your system. So if that is
For your
exceeded,
system.
that's supposed to damage your. Please, Mr. Somto, can you meet? So if that is exceeded, that has a tendency to damage your system, right? But the fact that maybe due to the kind of safety interlock that the OEM has provided, someone has done that and it is working, does not make it a safe practice. The safe practice, like we have all discussed, from Moses to Mr. Robert, it's try and make sure that there is no mismatch, right? That is the safe practice. That is the most safest practice, and that is what it should be. That's the ideal thing, right? Like even Moses say, you even try to create an allowance. They've given you an MPPT range, say maybe from 160 to 450. Try to keep it within, not at the extreme end. No, don't try to give an allowance, because that's what a good designer does. So when you are designing as an engineer, there is a place for tolerance. The OEM has provided tolerance in their system, which they may not let you know. You as an engineer, so in case, you also have to create that tolerance. So make sure that you keep your parameters within recommended by the OEM. That is the safest practice. So if someone said he's doing it and it's working, fine. You can be working every day for the thief, one day for the owner, and that's why we have a lot of problems. And that's why most times we say that the OEM, they will not honor their warranty terms. Yes, because the practices out there are quite not in compliance with what the OEM has recommended. So how do you expect the OEM now to work? So if you have done, someone say you should not exceed, for example, a maximum input of 12 amps, and then you go and put something that the rating of the resultant rating, current rating of your array is 15 or is even 18. Then by the time the OEM comes to the site to actually look at what you have done, and he finds out that it's 18. I get in. I don't tell you that by the virtue of that, you have violated the term of the warranty. You will now start shouting up and down. So the thing is, let's not overdo things. And I want to also add a voice to what Moses has already said. As installers, let me tell you, we are the most important stakeholders in this clean energy transition. I said it at the beginning, because You see, a lot of people have actually had their confidence in this clean energy dampened. Like Mr. Moses said, like if you go to India, if you go to Germany, they are already exceeding 1,000 or hundreds of megawatts from solar alone, right? From solar alone, I might even say mega, they are talking of giga now. From solar alone, tens to hundreds of gigawatt from solar alone, right? So then someone that is trying to set up a system that is not even up to even 500 kilowatts, it's not even up to 20 kilowatts, is already having doubts. The reason being that we are not meeting up, we are not doing what we should do. And at the end of the day, you hear people say, forget this one, a solar thing, they work, because you want to cut corner. So they see, I encourage people who are out there who actually know what they are doing to keep to the standard, right? Just try to carve a market for yourself. Don't say because people they get cheaper offer, may yourself, let me also lower my guard so that I can also, yes, I know you need to survive, but then if you can endure, and keep the standard, you will end up carving a market for yourself. There are people out there who are looking for professional people that know what they are doing, right? Who know their, honors. So if you end up becoming one, you have a market. People will come looking for you. You just need to do 4, 5, 10 good jobs, and then you are just made for, right? So by word of recommendation, people will say, that guy good. He did expensive, but the guy good. You never hear him before. They will say, that guy is expensive, but sometimes when you want to repair your car, they will tell you that guy is very good, but man, the guy is pricey. And most times people don't even mind. They don't mind having a good service and pay a little more. So that is why I'm saying that as engineers, let's try and ensure that we play our role, in the chains of energy transition in that we are doing, clean energy transition, and the role we're going to play is ensuring that we ensure that we boost the end user's confidence in this very renewable energy stuff we're talking about. Let's see how we can sift out those very unqualified and those who are just very much more concerned about money alone out of the market. And the only way we can do it is by keeping to the standards. Thank you. Let me not talk too much.
Just to add to the question asked by Emmanuel Joe Titus on the group chat, I think Christopher has said everything. Don't follow the bandwagons. Just stick to what the the data sheet is saying. And the reason why it might not get fried up, the charge controller, there is what we call clipping. All right, there is what we call clipping. Clipping simply means power loss. All right, which simply means that if an inverter is saying 500 watts and you are exceeding that 500 watts, it will clip. You understand? Like power will be lost. The rest, your inverter can just shut down. So at that period, you are not generating anything. You understand? And what is the essence of you installing solar panel when you are not able to use it? That's the reason why you see most people, they will say they are not getting efficient energy from what they've installed. It's simply because of that clipping. They've oversized more than what the charge controller or inverter can carry. Though it won't damage it, but you just realize that it cannot get to that point. That is loss of power, which is clipping. So stick to the rule from the data sheet, design accordingly, and you are good to go. Any other question? I think we have 1 more minute. Hilary, I've answered your question. Do you want to ask another question?
Yes, I do want to ask another question, and thank you for answering my question. Though I was not here, Mr. Christopher was able
Christopher
to.
is happy. Yeah, good.
He also gave some insights to my question. So what I wanted to ask is to Mr. Roberts of Growat, right? If I'm not mistaken. So when he was doing his data sheet, I'll try to be fast. He presented something to us where he says MPPT voltage range between 125 or thereabouts to I think 450, and later he was trying to advise us that we should make it to be 150. So doesn't it think that it could actually impact engineers? Because most of the time we want to build a system and give room for upscaling. So if a client says, okay, this is what I want, I could only be able to afford so numbers of panel, and we design it to that number of panel to give us exactly probably 123 or 140 range, and it appears to be that the scene is not picking up. Don't you think it has placed engineers on a dicey position, because it now feels as if we are not real to our customer. We want them to go and buy more panels, whereas we've designed according to what we have. So I want to advise that the Google might probably need to go back and adjust that aspect of their data sheet. So they need to go back, do more testing, and after confirmation, please, they should need to update that data sheet so that you doesn't put us into trouble. We are the bottom line. That's just what I have to say. Thank you.
Hello, Mr. Joseph. Thank you
I don't think they need to go
for
update
pointing
it.
out that.
But
Okay. So thank you for pointing out that. So we
Roberto,
have
answer
noticed
him,
this.
please.
We have noticed this for some time now. You know, the people that prepare the data sheet, they are not the one on the field using this system. So over the years, that is when we gather this experience. You understand? So if there is need to update the data sheet, we will do. But I don't think this should actually be a problem, because I don't see a reason why you will get a high voltage inverter that will allow you to use up to 450 VDC from your solar array, and then you now end up configuring your total VOC from the panel to be 120. So most people don't actually fall victim, but for as many that have reached out to us because of this issue, what we advise them is to add more panel, and then that has been the only solution for now. So we'll make room for improvement, or especially in updating the technical data based on real life scenarios. Thank you.
Oh, Mr. Kolawole hand is up. You can go on. Let's take this. This will be the last question. Mr. Kolawole, you can go on. Okay, since he's not here with us, do we have any? Let's take one last question. Any other or contribution? Okay. Diamond Power Tech, you can go on.
All right. Thank you, everyone. Good morning. I can see some familiar faces here. Mr. Robert, I greet you. This is Chris.
I greet you, my leader.
Okay. Energypro, I really want to thank you for the privilege you have given today, and this seminar has been really exciting. I just wanted to touch on some things as regard the question that has been asked by our wonderful technician or engineer here, Mr. Joseph Hilary. Well, there is something you should know when it comes to data sheets and the rest worldwide. As a trained professional, you are not expected to project at minimum. That is why you have a plus or minus 10% standard rule for whatever anytime you are designing a system company and relating it to the specification of the data sheet, be it in electrical system, mechanical system, or whatever. So in order not to fall that prey, as we have said, it is never advisable as an engineer to use manuals at their minimum, or to follow specification or data sheets at their minimum, or to use their minimum as your starting point. So it's always advisable you add a tolerance or a level of let's say 10 to 15%. So I think if you have that principle, I think it will help you not only when it comes to electrical and inverter system and engineering field worldwide. So thank you about that. I think I think that I had other things to say, but I lost my train of thought. Thank you, everyone. And for the man that, the engineer that was talking about him maintaining his dignity and his standards, you have to hold on to that. Like, for example, now, one of the things that made my own side stand out because I will be specialized in repair of inverter system and the rest. One thing that made us stand out from other sites is because we maintain a certain standard. Our price range are not the same with other repair center, but people that needs a quality repair services, they still find us wherever we are. That is why, for example, Mr. Robert from Growats can actually find us to our company and the rest. So you just need to stand your ground. You just need to stand your ground and do what you do and make sure you are good at it and make sure your word is it, because that thing, that standing your ground, it will come and speak for you one day. It will truly speak for you one day. They have so many people that are repairing Alaba, Arena, and the rest. But you cannot see, you will not see a top, the director of Blocks Power or anything going to visit them to take their inverter to them. But they can actually come to us because they know with words, with information they've gotten, we are kind of people that when we even repair your inverters, we still give you warranty on top. So we don't get as much repair as those people that are in the market that will just wait and take. We don't get half of what they get. But the little we get, we know that we say we can even sleep well at night. So I would advise you to stand your ground. You can try to improve yourself and see how you can be more creative. Most times it can be a budget too, but your marketing skills might not really be top notch. So you can
So you can
because the customer might, let's say you give the customer a
give the customer
1.5
a
billion
1.5
naira
billion naira
as
as
his budget, and the customer will tell you no, you don't know, you're seeing it for 900,000, and you can go and somebody with a better marketing strategy and a better way of speaking can turn the customer head, and the customer end up paying
paying
2 million naira for that same thing. So you just need to know that okay, if that is not your
that is not
strength, you
your
can
strength, you
employ
can
someone
employ someone
that is very good
that
at
is
that. That
very
is
good
why it's
at that.
called
That is why it's
division
called
of labor.
division of labor.
So
So
I think that's my
I think
advice for
that's
you.
my advice
Thank you
for
very
you.
much.
Thank you very much.
Thank you very much. So our time is fast spent. So let's continue this in the community. For others register, we'll try and send an email. If you would like to join us in the community, let's continue the discussion. Thank you, Mr. Moses. Thank you, Mr. Christopher. Thank you, Mr. Robert. Um, this will be the end of this particular webinar, but we are still on. Thank you so much. Thank you, everybody.
All right,
I
thanks,
thank
guys,
you guys
for
for
joining. Thank you for
joining.
the
Thank you for
discussion.
the discussion.
Bye, everybody.
Bye, everybody.
Bye.
All right. All right.
Uh, Oh, the
The
diamond tech.
diamond check.
Sir? Who said the
Who said the
grammar?
diamond guy?
Hello.
Hello.
Not a cut.
What's up?
So here I use 27 router. Now to see your router, just come to this side. Network device here. Network device, you are going to see a lot of routers here. 2911, 2811, and these are 2911. This way you are going to pick it out. I still believe you know where to pick your switch and your devices here. But 2911 are available. Now, if I have switching, also I wish you to switch. But for now, switch time will be first one. So my go on the here. So here, Mama. Come on, Yari. This is the the passion for telling. Ṣé wọ́n tì í sí? Yóò lè jẹ́ pé ìyẹ̀kan lọ́wọ́ advice ní kẹwàá ṣe. Kò ní bí èmi ṣé wọ́n tì í sí. Ìyẹn passion for it before. Máa ṣe o. Kí ni ìwà fọkùnrin pé òde ṣe? Láti ìlú ẹni. Minus. Láti ní system gbogbo ilé máa yí sí. Àìdí system nínú. Ẹ bá ní system máa yí sí. Orí ìgbọ́ tẹ́wọ̀ pé ẹ̀gẹ́ẹ̀tì inú kíláàsì ẹ fẹ́ délé ẹ̀yẹ̀ ó tẹ́wọ̀n nǹkan tó ṣẹlẹ̀ tẹ́lẹ̀ gẹ́ẹ̀tì. Láti wọlé sọ pé nọ́mbà 1 tí ìṣẹ̀lẹ̀ ẹ ọkọ̀ máa ní. Ilé ìwà ẹ̀ lè ló ń gbà ẹ̀wọ̀ tí mo ní gẹ́gẹ́ bí mo lórí. Olúwo ìsọ pé gbá kí gbára sí ilé tí ó máa ń gbá ní ìlú máa ń tọ́ ló máa lọ ní ìbọ̀. Ó lè dàbí.